Welcome back to the second lecture on wireless sensor networks. So in the first lecture we discussed about the various fundamentals of wireless sensor networks. So let us come to the MAC protocols. So as we know, the MAC and the routing layers are the most active research areas in wireless sensor networks. So as we know, at MAC layer we have two types of schemes available, that is called to broadcast the channel among the competing nodes, like static channel allocation as well as dynamic channel allocation. When the number of active sensor nodes changes dynamically and data becomes bursty at arbitrary sensor nodes, and it is most advisable to use dynamic channel allocation schemes. So as we have these sensor nodes or the sensor networks are designed to operate for a long time, as it is rather impractical to replenish the batteries. So the measurements have shown that the typical radio consumes the similar level of energy in the idle mode as in receiving mode. So the self-organizing MAC, or simply SMACs, networks and EAR are the two protocols, US drop and register, which handle network initialization and mobility support respectively. So let us discuss more about the sensor MAC protocol. So in this, in general, sensor MAC is an infrastructure building protocol, and that forms a flat topology for these sensor networks. And these SMACs are distributed protocol which enables a collection of sensor nodes to discover their what we can call that as discover their neighbors and establish transmission as well as reception schedules for communicating with them without the need of any local as well as global master nodes. So before each sensor node starts the periodic sleep, it needs to choose a schedule and broadcast to its neighbors. It has to inform to its neighbors by stating, I am going to sleeping mode. So to prevent long-term clock drift, so each sensor node periodically broadcasts its schedule as the sync packet. So SMACs, in order to achieve this ease of formation, SMACs combines the neighbor discovery as well as channel assessment phases. In SMACs, assign a channel to a link immediately after the link enhances is discovered. This way, links begin to form concurrently throughout the network. By the time of all nodes here, all their neighbors, they would have formed a connected network. So in a connected network, there exists at least one multi-hop path between two distinct nodes. Since only partial information about radio connectivity in a sensor network is used to assign time intervals to links, there is a potential for time collisions with slots assigned to adjacent links, whose existence is not known at the time of channel assignment. To reduce the likelihood of collisions, each link required to operate at the different frequencies. So this frequency band is chosen at random form, a large pool of possible choices when links are formed. Let us assume, if we consider the topology with various nodes, if we have to transmit the data between the nodes, so we will see how this SMAC will work. So a sensor node first listens for a fixed amount of time, which is at least the period for sensing a sync packet, like a sync packet. So if it receives sync packet from any of its neighbors, it will follow that schedule by setting its own schedule to be the same. Otherwise, the sensor will choose an independent schedule after the listen to that particular period, listening period. So if you consider EAR, US drop and register, so like in SMAC, so the method by which sensor networks find each other and the scheme by which time slots and operating frequencies are determined consecutive and important part of SMAC. So these nodes are engaged in the process of finding the neighbors and wake up the random times. So upon waking up, each node listens to the channel on a fixed frequency for some random time duration. So the node decides to transmit an invitation by the end of initial listening time. So if it hasn't heard any invitations from other nodes, it will check. So this is what happens to node C, which broadcasts the invitation or type message like this. So here in the case of EAR, so this algorithm employs the basically four primary messages, that is broadcast invite, in which this is used by stationary node to invite other nodes to join, and multiple base stations are received, and mobile node continues to register every stationary node encountered until it register becomes full. And other message called mobile invite. So in this case, this message sent by the mobile node in response to the above message broadcast invite BI message from the stationary node for the establishing the connection. So another message may send called mobile response. So this is sent by the stationary node in response to MI message, mobile invite message, and indicates the acceptance of MI request, which causes the stationary node to select slots along the TDMA frame for communication, and stationary node will enter the mobile node in its own registry. Mobile disconnect. So with this message, the mobile node informs the stationary node about the disconnection, and for energy saving purposes, no response is needed from the stationary node. These are the four basic messages which are transmitted by EAR algorithm. The number one is broadcast invite, second one mobile invite, third mobile response, fourth mobile disconnect. These are the four messages. So thus this protocol attempts to offer continuous service to these mobile nodes under both mobile and stationary constraints. So another protocol called STEM. So in this, the STEM may seem better suitable for reactive sensor networks, where the network is in the monitoring state for vast majority of time. So as an example, a sensor network designed to detect fires in forest. So there is no need of operation frequently. Simply it will monitor the environment for long period of time. When any disaster occurs, then it will sense. So these networks have to remain operational for months or years, but sensing only on the occurrence of forest fire. So the main idea behind the STEM protocol is to turn on only the node sensor and some processing circuitry during the monitoring states. Whenever a possible event is detected, the main processor is woken up to analyze the sensed data in detail and forward to the data sink. However, the radio of the next hop in the path to the data sink is still turned off, so it did not detect any event. So STEM solves this problem by having each node to periodically turn on its radio for short time to listen if some else otherwise wants to communicate with it. So the node that wants to communicate, that is the initiator of sensor network or sensor node, sends out the beacon with the ID of the node it is trying to wake up. That is the destination sensor node. So this can be viewed as a procedure by which the initiator sensor node attempts to activate the link between itself and the target sensor node. So as soon as the target sensor node receives this beacon, it responds back to the initiator node and both keep their radio at this point. Like this. So whenever they need, they are communicating with each other by periodically activating on. So if the packets needs to be relayed further, the target sensor node will become the initiator node for the next hop and process is repeated. Once both the nodes that make up the link have been the radio on, the link is active and can be used for subsequent packets. However, the actual data transmission may still interfere with the wake-up protocol. So to overcome this problem, STEM proposes the wake-up protocol and the data transmitter to employ different frequency bands as per the requirements. So in addition to separate radios would be needed to each of these bands. So STEM refers to these communications as occurring in the wake-up plan. Once the initiator sensor node has successfully notified the target sensor node, both sensor nodes turn on their radio that operates in frequency band. So the actual data packets are transmitted in this band called data plane. So this is example. So we have first we need to wake up, then data has to be transmitted. Once after activating, the data is transmitted. So for this, the sensor node, the initiator node has to find where the destination is. It has to find the location discovery. So during aggregation of sensor data, the location information of the sensors must be considered. Each node's couples its location information with the data in the message it sends. Just like GPS is not always visible because it cannot reach the nodes in dense or indoor, and it consumes high power. So we need low power, inexpensive and reasonably accurate mechanism. So for this we need to localize the sensor networks. So in these situations where there is no fixed infrastructure is available, some of the sensor nodes themselves acts as beacons. So using GPS, the beacon nodes have their location information and sensed periodic beacons or signal to other nodes. So in the case of communication using radio frequency signals, the received signal strength indicator, that is we can call it as RSSI, can be used to estimate the distance. The time difference between beacon arrivals from the different nodes can be used to estimate the location. There are several multilateration techniques, so we'll discuss later after this leap. So once we find the location of the sensor, destination sensor, and once we localize the sensor networks, so then another protocol called localized encryption and authentication protocol. So in this, it uses different keying mechanisms for the different packets depending on their security requirements. Every sensor node maintains 4 types of keys like individual key, group key, cluster key, pairwise share key, which is used for share with each neighbor, whereas the cluster key which will share between node and its neighbors. Group key share with all the nodes within that particular group or under the base station. So individual key as well as individual key is represented for the to represent that particular sensor node. So as we know, there is no one to get the common key. It is impossible to index the false data or the decrypt earlier exchanged message. So no node can later force the master key of any other node. So in this way, pairwise shared key are generated between all immediate neighbors. So then group key is established by the cluster key. So another protocol called SAR. So in SAR, the sequential assignment routing algorithms creates multiple trees where the root of each tree is one hoop neighbor of that particular sink. So the routing scheme in this SAR, sequential assessment routing, depends on three factors. One is energy resources and quality of service on each path, then priority level of each packet. So to avoid single root failures, a multi-path approach is coupled with localized path restoration scheme, and to create multiple paths from source node, a tree rooted at the source node to destination nodes is constructed, and the path of the tree are defined by the avoiding nodes with low energy or quality of service. At the end of this process, each sensor node is a part of multipath tree. Sorry. For each sensor node, two matrices are associated with each path, that is delay and quality of service, or that is energy usage for routing in that path. So the energy is measured with respect to how many packets will transfer that particular path. SAR calculates the weighted quality of service metric as the product of the additive quality of service metric as a weight coefficient associated with the priority level of the particular packet. The goal of the sequential assessment routing is to minimize the average weighted quality of service metric for that particular network. So each sensor node, it will record two parameters about each path, that is available energy resources on the path and quality of service metric such as delay. So this is an example for SAR. So next we'll go for another protocol called incense. So in incense, the protocol, we can call this protocol cannot totally rule out attack on nodes, but minimizes the damage caused to that particular network. So these instances are having two phases. Again, one is root discovery and second one is data forwarding. So in root discovery phase, the base station send a request message to all the nodes in the network by using multi-hop. Any node receiving a request record the ID of the sender, and the nodes respond with their local topology by sending the feedback. The messages are protected using shared key mechanism. Base station calculates the forwarding table for all the nodes, and data forwarding phase, so transport data by using the routing table. So control information about the routing must be authenticated by the base station to prevent injection or the false data. So another protocol for meant for security protocol for sensor networks. So in this there are two highly resource constrained sensor networks which is having two modules, and sensor network encryption protocol micro version of time, that is MTELSA. You can call this as time efficient streaming loss tolerant authentication protocol. So in SNAP, provide data authentication and protection from reply attack. Semantic encrypted, the same message is encrypted differently at different instance in time. Message integrity and confidentiality are maintained using by authentication code, just like MAC. And in micro version of time efficient streaming loss tolerant authentication protocol, the MAC keys are obtained from chain of key and one-way function. So all nodes have initial key K0, and which is some key in the key chain, that is the subsequent keys, that is which are represented as K0 equal to function of K1, K1 is equal to function of K2, like that. Ki is equal to function of Ki plus 1, and given Ki2, K0 to Ki, it is impossible to compute Ki plus 1. So as we know, if you want to find the destination, when the data is transmitted from source to destination, the source has to find where the destination is. We need to find the location discovery. So in this location discovery, each node couples its location information with the data in the messages to when it is sending to its neighbors. So in some cases GPS is also used, but in this case we need to have GPS is using more power. That's why we need to have low power and less expensive, reasonably accurate mechanism. When we come to the quality of sensor networks, so in this quality, the main purpose of the sensor network is to monitor and reports event taken place in one particular area. So hence, main parameter which define how well the network observes the given area, that is it will cover. So like any standards, the wireless sensor networks is also having the standards which is comes under 802.15.4 wireless personal area network, as we said in the previous lecture. And a low data rate solution with multi-year battery life and very low complexity. It intended to operate on in an unlicensed international frequency band like the visible spectrum. So this standard defined the physical and MAC layer specifications for sensor and other wireless personal area network. Low power consumption is an important feature targeted by the standard. So this required the reduced transmission rate, power efficient modulation techniques, and strict power management techniques such as sleep modes. So we need to have a new alternative approaches or algorithms we need to design to maintain these things. So the standards called SenseIT project by DARPA, which focuses on large size distributed military systems. So if it comes to transport layer issues, so in general, transport layer, it will deliver the reliable data. So these are two protocols we have, that is pump slow and fetch quickly, event to sync reliable transport protocol. These two are the protocols in transport layer. When we come to pump slow, fetch quickly, so it assumes that data loss due to poor link rather than traffic congestion. The major concept is source node distributes the data at a slow rate. The receiver node, which experiences data loss, retrieve the missing data from immediate neighbors very quickly. So pumping means in these three major steps are going to be performed. One is pump, second one is fetch, and third one is report. So pump is called as message relaying, fetch, error recovery, report, and selective status reporting. So in the first function called pump, in this disseminates data to all the target nodes, perform flow control, and localizes loss by ensuring the caching of intermediate nodes. Hence, the errors on one link are corrected locally without propagating them down the entire path. The second function, fetching, the receiver detects the loss of sequence numbers. It goes into the fetch mode. It requests the retransmission from the neighbor nodes. So many message losses are batched into single fetch, which is especially suited for bursty losses. In the third function, reporting, the farthest target include initiates its reports on the reverse path of data, and all the intermediate nodes add their report to the existing message which is transmitted. In ESRT, event to single level transport, so in this place of end-to-end reliability by transport layer, so it is observed reliability, that is number of packets that are routed from event to sink, required reliability, the desired number of packets per event successfully tracked. So if the observed reliability is less than the required reliability, ESRT increase the report frequency, otherwise decrease the reporting frequency for saving energy. So these are the enabled technologies in wireless sensor networks, like embedded numerous distributed devices to monitor and interact with physical world, network devices to coordinate and perform high-level tasks, exploit spatially and temporally dense in-situation sensing and actuation, in sensing tightly coupled to physical world, in networking exploit collaborative sensing as well as action, control system with a small form factor and the third nodes. These are the enabled technologies where the wireless sensor networks. So as we consider the future technology, the future of wireless sensor networks, smart homes as well as smart offices, in biomedical as well as medical field we can use, like glucose, heart rate, cancer detection, artificial retina, and monitor vital signs, record anomalies. As well, industrial as well as commercial, we can use agriculture crop conditions, inventory tracking, in-process parts tracking, automated problem reporting, RFID, plant equipment. In all these cases, as we traffic management, in future we are going to use sensor networks. So the various simulation tools we have for these sensor networks are Sense, SSFNet, GLOSIM, MSP SIM, and WSNet, as well as Castelia, Manazim, OPNet. These are the various simulation tools based on our requirement we can use. For example, if you use OPNet, use it to provide performance management for computer networks. So in this case, we can also use NS2 as well as NS3. These are the references and the scope of research. We have still a research scope in these areas, that is unmanned autonomous aerial vehicle technologies using wireless sensor network, infrastructures for energy data collection and analysis in networked manufacturing plants using wireless sensor networks, in agriculture sector, energy optimization in heterogeneous networks. So how we are optimizing energy conditions, energy consumption in when you are integrating different kinds of networks. Localization, new routing protocols instead of multi-hop, technology and coverage control, deployment techniques, WSN in healthcare applications, wireless body area network security, Internet of Things and applications, energy efficiency, MAC and routing layers. So these are the various scopes of research in wireless sensor networks. So if you have any queries, you can contact me at any time. Thank you.